We're going to talk about dissociation and what dissociation means, especially in terms of water, because it happens a lot in water, and it's important for us to know what's going on with water. So I'm going to draw a water molecule here. We have our oxygen, and it's attached to two hydrogens. And each of these hydrogens is a proton, right? There's not typically neutrons in hydrogens. Sometimes there are, but for most part, we're just dealing with oxygen attached to two hydrogens, each that have no neutrons, so they're only a proton. And if water is just chilling in solution, sometimes what happens is it will break down and lose a hydrogen just spontaneously. So we'll end up with something that looks like an oxygen attached to a hydrogen that has a negative charge and an H plus ion. Okay, so you see, hopefully you can see that these are the same thing. It's just that this one's come apart a little bit here. And what often happens with this H plus ion is it will go over here and find another H2O and attach itself and create H3O plus. Okay, these two things both contribute to acidity. This contributes to basicity. So if you think about it, if I've got like a jar of water, a beaker of water, and it's spontaneously dissociating and not dissociating, the basicity and acidity that it creates are going to cancel each other out because the ratio between the two is going to be the same, because if one water molecule breaks down, it's going to create one H plus and one OH minus, each of which will cancel each other out. And that's why water has a neutral pH. Even though it does dissociate a little bit, it does have a neutral pH. And I'm going to try and post another YouTube video that kind of shows an animation of this happening, because my drawing is not always perfect, but that's what's going on there. Slide right here just talks about what I was just talking about on the whiteboard. So water and water will dissociate into H3O plus and OH minus. And if OH minus is basic and H3O plus is acidic, those will cancel each other out, and it will eventually have a neutral pH. Now, all of this right here, all of this stuff is math that essentially says here is the concentration or the equilibrium constant of that dissociation happening. The important thing to know here is that the value of the dissociation is 1 times 10 to the negative 14, which is the concentration of H3O plus and the concentration of OH minus multiplied together. That might be super confusing right now, but honestly, it's not that important at this moment. The main thing that I want you to take away is that water will dissociate and combine itself back together. But because when it dissociates, it creates one acid and one base particle, they cancel each other out. And that's why water is neutral. So then let's talk about the pH scale here. And the pH scale is something that most of us are a little bit more familiar with. pH is going to indicate the acidity or how acidic something is of a water-based solution. So if there's no water in the solution, pH doesn't really work. And you can see over here on this side right here, let me see if I can make this bigger. There we go. So you can see on the side over here, we have the concentration of H plus. As the concentration of H plus increases, the pH is going to go down. So you can see right up top here, concentration of hydrogen ions compared to distilled water. And so at 10 million compared to distilled water, that's a huge amount of H plus. Your pH is 0, and that's going to be stuff like super strong hydrofluoric acid, battery acid, that kind of thing. And then as you move down the pH scale, the concentration of H plus decreases and the pH number increases. This can be kind of hard for us sometimes. So just think of it, it's opposite, higher H plus content, lower pH number. And you can see some different examples here. We have hydrochloric acid, lemon juice, down to water at a pH of 7, which is neutral. That's something that you need to know. pH of 7 is neutral. No acidity or basicity, it's neutral. And then it goes on. Now I give you this formula right here. Whoops. This pH is equal to the negative log of H3O plus. And I'll be doing some more math on the whiteboard so that you can kind of see exactly what that means, because it can be kind of complicated. But a logarithm is a way of finding an exponent as a variable. You'll learn about this in junior math, but if you haven't done it already, just know that it is a calculator function. You don't need to be worried about doing some new math. Your calculator can do this. Your cell phone calculator can do this as well. I will try and show a couple different calculators and what they do so that you can kind of get a feel for it here. But basically what happened here, and this is why pH was created, it was created because of alcohol. So a scientist was trying to come up with a way to measure the acidity and basicity of alcohol because it does affect flavor. The problem is that concentrations of H+, even in super acidic solutions, tend to be really low. 1 times 10 to the negative 7, for example, that's not that concentrated. We've got a lot of 0.00000 there. And so what they do is they use a logarithm so that they don't have to write all those zeros. And I'll show you this again on the whiteboard here in just a second. But this formula, pH is equal to the negative log of the concentration of H3O+. That is something that you should write down in your notes. That's something that you're going to need to do. It's some math that you're going to need to do. It looks really scary, but it's going to be okay. So we're going to do some practice math. I'm going to do these problems over on the whiteboard with everybody so that we can do a walkthrough step by step. And you'll see that it's actually pretty simple. All right. Before we really get started, I just want to point out that the button we're going to use right here is this button right here. You can see my reflection. This button is logarithm, and you'll see that taking the log of 0 isn't possible, but this button right here is the one you're going to want to find. Some of you, it will be a second button on your calculator. Some of you, it will be its own button. Try and find it. If you need to use Google to find and use their logarithm calculator, that's fine too. So the formula for pH is that pH is equal to the negative log of the concentration of H3O+ in molarity. Looks really scary because there's lots of letters going on, but fortunately it's going to be easier than you think. So I give, for our first practice problem here, I'm going to give you the concentration of H3O+ is equal to 1 times 10 to the 8th, or excuse me, negative 8. Okay, so this is our first problem. If the concentration is equal to 1 times 10 to the 8 molar, okay, what's pH? So this is what we're going to do, is we're going to go ahead, we're going to take our formula and we're going to plug everything in, and I'm going to use a different color for this. So pH is what we're trying to find, so that stays blank, that stays normal. And then I'm going to go ahead and write negative log, and then in parentheses, I'm going to put this number here. So that becomes 1 times 10 to the negative 8. Now from here, you can plug it into your calculator. Now, some of us have a hard time with the whole times 10 to the, so be careful here. But I'm going to go ahead and do it on my calculator and see if I can show it on the screen here. There we go. The concentration is equal to 1 times 10 to the negative 8. And we need to find negative log of 1 times 10 to the negative 8. Here we go. This is how we're going to do it. We're going to go ahead. Come on, phone. We can do it. All right, we're going to go 1e, because that button means times 10 to the, and then we're going to go negative 8. So you can see right there, that's 1 times 10 to the negative 8. I can hit equals. Then I'm going to go ahead and take the log, and I'm going to make it positive. Okay, my answer is 8. So again, here's our formula. pH is equal to the negative log, and in this time is 5.24 times 10 to the negative 5. What you're going to do is you're going to take this number, you're going to take the log of it, you're going to make that number the opposite sign, positive or negative. You can have negative pH. It won't often happen, but it can happen. In this case, I got 4.28. Make sure that you are able to plug this into your calculator on your own, because I won't be there with you to guide you through as you're taking quizzes and that kind of thing. So try this one on your own, see if you can get it. Let's do another practice problem here. Here's one more. 6.7 times 10 to the negative 11. Try this one by yourself and see what happens. See if you can get it correctly. Pause the video, do the math, and then compare when I smack the answer up here in just a second. All right, the answer to this one is that the pH is equal to 10.17-ish. If you didn't get that, double check your math. Make sure that you're punching everything into the calculator correctly. If you got negative 10, you forgot to change the sign at the end. So make sure that you do that. All right, so another number that you probably aren't familiar with is pOH. And pOH is just the opposite of pH. It's not measuring the concentration of H+. Instead, it's measuring the negative log of the concentration of OH-. Now, you'll remember that with water, the concentration of H+ and the concentration of OH- should be the same thing. But in other substances, so if you have a water solution mixed with a strong base, it's not going to be the same thing, because you're adding strong base, you're going to be adding OH- to the solution. So your concentrations will be different, and pOH is a different number. So in this case right here, we have pOH is equal to the negative log of the concentration of OH-. Now, the good news is that you calculate it in the exact same way. I give you the concentration of OH-, and you plug it in, you find the log of it, you make the sign different, and that's the end. So in this case right here, 1.2 times 10 to the negative 8 Pause the video, see if you can figure this one out on your own, and then resume it once you think you've got the answer. In this case, our pOH will be 7.9. If you didn't get 7.9, check your math, make sure that you're plugging everything in correctly. All right, so now what happens if I give you a pH or a pOH and I want you to find concentration from that number? It's super easy. These are your formulas. The concentration of H3O plus is equal to 10 to the negative pH. That's it. So you take your pH, you make it negative, you put 10 to that exponent, and there's your concentration. Same thing with pOH and the concentration of OH. So if I give you one or the other, you should be able to find the next one. So I'm going to do some of these practice problems again on the whiteboard. Okay, so we're going to do some practice with this one. I've got my concentration of H3O plus is equal to 10 to the negative pH. So let's say that I give you this problem right here. I say that the pH is equal to 12.2. I want you to find the concentration of H3O plus. See if you can do that on your own. I'm willing to bet a lot of you can, but if you can't, just watch and we'll see how I do it here. So if I know that the concentration of H3O plus is equal to 10 to the negative pH, this is easy. I'm just going to say 10 to the negative pH, in this case, is 12.2. And I'm going to plug that into my calculator. Got this number right here, 6.3 times 10 to the negative 13. That should be your concentration of H3O plus. If you got that wrong, check your calculator. Make sure that you're punching everything in correctly. Let's do a couple more practice problems here. All right, so what about this one right here where we have pOH is equal to 11.98 and we need to know the concentration of OH minus. Well, this formula doesn't technically match, but if you are smart, you know that OH minus is equal to 10 to the negative pOH. And so it's kind of the same formula. We can plug it in the exact same way. And so we're going to go, okay, 10 to the negative 11.98, and we'll find that our pOH value is 1.04 times 10 to the negative 12. Okay, that's our pOH value right there. Now, I want to remind you guys, if you're off by just a couple decimal places, so if you rounded and you got 1.05 times 10 to the negative 12, I'm okay with that. You're going to be just fine on the test. You'll be all right. And that's how you calculate concentration from going backwards.